This is Professor Derek Seitz. This video shows how to do hypothesis testing for goodness of fit using Microsoft Excel. The idea here is that you're given a distribution of categories, which is referred to in this sheet as the basis, and the categories are given as percents. So in this example, there are 5 categories with 4%, 65%. In this category, 13% in the third one. That's the basis. And then you want to determine if a given distribution that you're looking at now follows this basis, whether it's a good fit for it. And what you have is observed frequencies for those categories listed here, each one associated next to a basis category. There's room for 25 categories. This sheet uses 5. You have to enter this data in the blue cells, the basis percents, and the observed frequencies. The only other thing you will need to enter over here is the level of significance for your test. For this example, it's 1%, and it's shown with 5 decimal places of precision for ease of comparison to the p-value. All the cells in white are calculated automatically based on this input data. Each expected value is calculated as a percent, the percent divided by 100, giving you a decimal version of a percent, times your absolute positioning, cell I-12, is the total. As you can see here, I-12 is the total of the observed values. That's your current population, the total items in there that make up those categories. And so each expected value is the basis percent times the total. And that gives you these 5 values here, and they're calculated all the way down. For the blank cells, the inactive ones that are not being used, the calculations result in 0, which do not adversely affect the test statistic. Since it's adding 0 does not change it. Then these next 3 columns calculate progressively towards the test statistic. Observed minus expected in this column, the square of that next, and that divided by E in the last column. And the test statistic is the sum of the values in the last column. The null hypothesis is that the population fits the specified basis distribution of categories. The alternative is that the population has a different distribution. The other calculations here, besides the test statistic, we'll come back to that in a minute. K, the number of categories, the non-blank rows, are 5. That's determined automatically by this count A function. The degrees of freedom is K minus 1, number of categories minus 1. Alpha, we've already mentioned, you have to input just so you can do the test. Going back to the test statistic, again, that's the sum of the last row. And the p-value, it uses the chi-square distribution, right tail passing in I4, which is the test statistic value, and I6, which is the degrees of freedom. It comes back with this p-value 0.00682. Down here, some things to check on. The total of the basis percents is calculated. It should add up to 100 as noted by the comment. That's a check you can do. The total of the observed values, whatever that is calculated here. And the total expected value should equal the total of the observed values according to the expectations being used. Check those out to make sure everything was done correctly, and then do your test. The p-value is smaller than the level of significance, which means there is significant evidence at the 1% level of significance to reject the null hypothesis and to decide at that level of significance that the population has a different distribution than the basis population.